All right, this one is question number 3. It says the graph of the function f is shown above for 0 to 3 of the following, which has the least value. So which of them is the smallest? Remember that the integral from 1 to 3, so the integral from 1 to 3, which is just this area right here. Let me use my pointer. So here's 1 and here's 3. So the integral from 1 to 3 would literally be the exact area under the curve. So if you almost like took a highlighter and highlighted that exact area under the curve, that would be the integral from 1 to 3. Excuse me. The next one down, the left Riemann sum approximation of the integral from 1 to 3 with 4 subintervals of equal length. So if I do a left Riemann sum approximation, remember I'm coming from the left, I only want to look from 1 to 3, and they want 4 subintervals, so I have to divide it like this. And if I do it that way, notice that all of my left ones are over. Alright, so those are all over approximations, which means that I know it's at least bigger than part A. So yeah, it's bigger than part A, so it's definitely not the answer because they want the least value. So far between A and B, A is smaller. If we look at part C, it says the right Riemann sum approximation with 4 subintervals. So again, I come back up here, and I put my little subintervals back up, but this time I'm coming from the right-hand side. So if I start over here at the right-hand side, notice that these are all smaller, alright? So they're all below the graph. And so if they're below the graph, that means they're an under approximation, which means that the area calculated would be the least amount so far. So between A, B, and C, C is the smallest amount. By the way, notice the patterns that appear with concavity. So if it's concave down and you're using left intervals, you're getting an over approximation. If it's concave down and you're using right intervals like this one, you're getting an under approximation. And the opposite is true for concave up. If it's concave up and you're using left, it's an under approximation. And concave down using right intervals would be an over approximation. So far C is the answer I'm going with. Let's see what D and E say. D is the midpoint and E is the trapezoidal sum. So let's see which would be bigger of those. I'm sorry, smaller of those. So for midpoint, I use my little four subintervals. And from the middle, it would be here, here, oops, that one's not very good, here, and here. So notice that some of it's under, some of it's over, but I think that kind of balances it out. The midpoint and the trapezoidal sum, just as a hint, always tend to fall between the left and right. So the left and rights are kind of the extreme of being the smallest or biggest, respectively, depending on if you're concave up or concave down. And then the midpoints and trapezoidals kind of balance themselves out because this happens a lot where part of it's on top and part of it's on bottom. So they kind of are very close to the actual area. So again, this one's in the middle. So still, the right Riemann sum is probably my best bet. And then if I just want to look at the trapezoid just to make sure, again, look how close that trapezoidal area is. It's pretty close, much closer than the right Riemann sum. So I would say of all of these answer choices, the right Riemann sum was definitely the least value. Because it was the smallest summation that we got when we added together all of those rectangles.